Hi, in this lesson, we'll take a look at recursive searching. In the last lesson, we were introduced to the idea of recursion. Put simply, recursion is when a method calls itself. We use this to help break problems down into smaller problems until we get to a simple form. As an example, we looked at summing numbers. The recursion utilizes a base case, which is our simplest form. If we are not in our base case, we use the recursive call. Each time we make a recursive call, we call a slightly simpler problem. Over the next couple of lessons, we are going to look at how we can use recursion to solve searches and sorts. This lesson will take a closer look at two different search algorithms, and we will look at sorts in the next lesson. Think back to Unit 7, where we looked at linear searches. We found that linear searches would check each element in order until we got to the specific item that we were looking for. Our solution to that problem involved a for loop, where we searched until that value was found. This process could be inefficient if we had a large list to look through. Binary searches offer a more efficient alternate technique. A binary search finds the middle of the array and tests that point. If the target is greater than the midpoint value, then the search eliminates the lower half. Likewise, if the target is less than the midpoint value, the top half can be eliminated. This process is then repeated, finding a new midpoint each time. One thing that is important to note is that the array must be sorted for a binary search. Here is a search in action. Notice how each iteration eliminates half of the values. While this process is slightly more efficient for smaller arrays, it is significantly more efficient for larger arrays. A linear search of 10,000 records could have a worst-case scenario of 10,000 comparisons. With binary search, our worst case is only 15 comparisons to find our value. When comparing our two searches, there are three important things to remember. First, our binary searches are much more efficient than our linear searches. Second, our linear searches will work on any array, but our binary searches only work on a sorted array. Finally, as we will see coming up, our algorithm for binary searches is a little more complex than our linear search. By their nature, binary searches are a lot more efficient than linear searches. Recall from Unit 7 that a linear search only eliminates one item each iteration. In a binary search, we eliminate half of the items each time. We can go through a large list very quickly this way. To calculate the maximum number of times a binary search will need to iterate through an array to find a value, we can use a log_2 function with the array size. The actual number may be plus or minus 1 depending on the implementation. Let's look at an example. Given an array of 512 items, what is the maximum number of iterations it will take to find an item? To calculate the solution, we use log_2 of 512. The solution is 9. Remember, logarithmic functions are the inverse of exponentials, so 2 to the 9th power equals 512. Let's take a look at the code needed for a binary search. First, we will look at doing this with an iterative loop. Notice in our loop how we calculate the midpoint, then test it before updating the beginning and ending points each time based on our results. Let's walk through this process. Our initial values come from the size of our array. We then calculate the midpoint and read the array at that index. On our first pass, we see that our target is greater than our midpoint value. We then update the beginning index to be the next index after that midpoint. We continue this process. Since the beginning is now 6 and our end has not changed, our midpoint shifts to 8. Remember, the average of 6 and 11 is actually 8.5, but since these values are integers, it gets truncated to 8. We now see that our target value is less than the value of our new midpoint. With this in mind, we adjust our endpoint and eliminate the top half of this iteration. In the final iteration, we see we only have two values remaining. The midpoint value is calculated as the same value as our beginning point in this case. On this third iteration, our midpoint that is tested is equal to our target number, and we return that value. As we saw in the last lesson, problems that are solved using a loop can also be solved using recursion. Let's take a look at how we can do a binary search with recursion. Let's now look at this problem as a recursive code. Remember, a recursive code calls a simpler problem each time through. In this case, each recursive call is essentially calling a smaller array until we get so small that we find our solution. The biggest change at the start of the code is that we are passing the beginning and ending values into our method. From there, we can calculate the midpoint the same way as before. Our base case is when we find our value. For this first iteration, we skip the base case using the recursive call. Our recursive call passes the original array, the target value, but then updates the starting point as it makes the call. The second call passes the 6 and 11 directly. We then calculate our midpoint and test the values again. On this second pass, our midpoint value is less than our target, so we make the third recursive call, adjusting the endpoint this time around. On our third call, we find that our target is found at the midpoint. Once the value is found, the index value of the target is then returned back through each of the recursive return statements until it eventually gets back to the original call statement. Why would we choose one approach over the other? Well, for a binary search, either approach offers roughly the same efficiency from a speed and memory perspective. In this lesson, we took a look at two different search algorithms, sequential or linear searches and binary searches. Binary searches can be significantly more efficient. However, they do require our lists to be sorted. A binary search can be done using either an iterative approach or a recursive approach. Binary searches eliminate half of the list each time through by testing the midpoint and adjusting the search parameters accordingly. Now that you've practiced using recursive searching, let's get some practice using it in the editor.